Alrighty, well, good afternoon, everyone, and welcome to week 10 of the ConsoliDator MasterClass. And so this is actually the second to last session that we're going to be having. So it's been a real fun last 10 weeks, and I'm glad to see that folks are still showing up and still asking questions and participating. So let's go ahead and get started. So today we're going to be talking about some schedules and timers. So we've seen quite a few times timers being used in our various slides. I've mentioned several times that we can schedule certain events and things of that nature. And so now we're going to finally take a look at how that all happens. So what we're going to go over today is how to schedule events based on day and time, whether that's turning on a pump or acknowledging an alarm or data logging or whatever it is that you need to do. We're also going to take a look at how to control and or alarm based on elapsed time. So that would be using a timer to see how long something has happened for. And then we're going to take a look at a tank filling application or a time to fill. And I'll show you what that means later. And then if we have time, I also have my demo set up with this application because it's actually a really clever application that I think people will like. So without further ado, let's go ahead and jump into scheduling events based on day and time. So for this particular scenario, what we want to do is we can create a channel, and the function, we're going to go into the control, the control functions, the control category, I should say, and we find schedule, which is right over here. Now, as it says in the notes, there are other ways to schedule certain events, but this is the best way. This is the smoothest way. So that's what we're going to learn. So once we find that function there, this is what the screen's going to look like. This is all the information that we're going to have to fill out. So the one thing that you're not going to have to worry about is unless you wanted to display this channel on a screen, which most folks I don't think are going to want to, you don't really have to worry about your units because there's really no reason to show it on screen, so you don't have to worry about that. All we're really worried about is telling the consolidator when to do something and when to stop doing that something, okay? And so you basically fill in your start and stop. And so we'll start with the start. Now, that can be, when you that drop-down box is going to be days of the week. And so you can pick one of any of the days of the week, or you could pick weekdays, or if you wanted to do something on the weekends, you could pick Sunday or Saturday. And so with this one, we're just choosing Sunday. And then we choose our function. And so now our function is going to be what the event is going to be. And so the events can be many different things. And it's basically, if you remember back to the soft keys, any function that the soft key can perform is basically what we can do here. And so if you look on the right side of the screen, we can do things like forcing on and off of relays. We can manipulate an output, change screens, or jump from one screen to another, or go to a specific screen, start and stop timers. There's all sorts of different things you can do. And so if you can do it with a function key or a soft key or a digital input, you can do it with the schedule function. So let me just erase that. And so we go to the next slide. This is where I show you where to type in the different, or not type in, but enter in the different functions. And so with this one, let's just say, for example, you have a customer that wants to turn on a pump every Sunday at noon and run it for a half hour. That's really all they want to do. They want to run a pump for a half hour. Well, to do that, we quite literally tell the consolidator when to start, which is Sunday at noon. And our function is to force on the relay that's tied to pump 1. So on Sunday at noon, the consolidator is going to force that relay on. Now, unless I actually put a stop parameter here, it would just leave that pump on forever and ever. So what we want to do is tell it when to stop. And so we want it to stop on the same day, on Sunday. And we want it to stop at noon 30, as I like to call it, or 12:30 p.m. That's when we want it to stop. And so instead of force on for the function, we're going to force off. So with this screen on Sunday at noon, our pump 1 relay is going to turn on. And then on Sunday at 12:30, it's going to turn off. Now, you can imagine the different things that we can do here with this scheduler. We're just talking about forcing on a pump for a little while, but let's say you wanted to force on an alarm or something, or you wanted to start a timer or even a data log. What if you wanted to start a data log on Sunday at 12:30? You can do all sorts of different things like that with the scheduler. And so obviously this is a very simple example, but it was just to show you the flexibility. You can imagine all the different things that you could do with this. And it's really nice, especially because if you wanted to do things only on weekdays, you wouldn't have to create you wouldn't have to create a schedule for every single day of the week. You could just do all weekdays, and you would only use one channel. So that's how we can use the consolidator to schedule events based on time and day. But what if we want to control or alarm based on elapsed time? And so that's another thing we can do with this device. And so just to set the scene here, I wrote up a little something. You don't have to read it all. I'll read it to you. So here it is basically. If your customer has a tank which cannot overfill or else it's big trouble. They have an alarm for when the tank rises to 80% capacity, and they are using the Consolidator Plus to monitor their tank level, and they also use the Consolidator Plus for their alarm. However, the external horn that they use has a silence button on it. It doesn't clear the alarm. It doesn't do anything aside from just make it not annoying. And the idea is that the operator can go do something else and then come back to the alarm when they're done. But what happens if they don't? What if they forget about that high-level alarm? Well, the solution is the Consolidator Plus can be used so that, let's say we get a high-level alarm, and after 20 minutes have passed and the alarm state is still there, no one's touched anything, we would like to set off another alarm so that we can maybe send a message to the control room or do something else. So basically what it is the alarm comes on. If that alarm stays in alarm condition for 20 minutes or longer, we're going to throw a bigger alarm. So how do we do that? Well, the first thing we want to do is we want to create, we already have our level channel. We already have our high level channel. So all we're doing is basically creating a new alarm off of that. And so what we do is we create this timer here. And the timer, for the input, it's going to be our high-level alarm. So that's the input to this timer. When that alarm is active, that's when we want to start timing. The other things that you have to pick out, or the other things you have to configure here are power up. And so that basically means what happens if power cycles to the unit. Do you want that timer to just start counting? Do you want it to stop if it's in the middle of counting? And so for the most part, I usually just do stop and reset. Because if you're going to cycle the power, you're probably just going to want to start from zero. So I leave it as stop and reset. But your options are stop and reset, reset, start, and stop. And I think maybe stay as is or not. So that's the first thing you do. Then we have error. So this tells the timer if there's an error of any kind on that alarm or on the input that's going into the alarm, like maybe you have a signal break, what do we want the timer to do in that case? And so for this example, I chose stay as is because if there is a break in the signal, that doesn't really affect how long the tank is being ignored. So I kept that stay as is. Now the other ones here, the start, stop, and reset, that is basically telling the consolidator when to start and stop. And so this is where it gets a little bit tricky, so it's important that we listen up here. So I'm going to this next slide here. The reset, start, and stop. This, again, it tells the consolidator when to start, stop, or reset the timer. And we have to think about this in terms of our alarm, okay? So we want to have this timer start when our high-level alarm triggers. And our high-level alarm triggers when our tank climbs to 80% capacity. So that means we want our timer to start when the tank is rising to the set point of our alarm. Okay, so hopefully that makes sense. We want this timer to start when the tank is rising to 80%, as opposed to if it was at, let's say, 90% and it was draining down to 80%, we don't want the timer to start then. We only care about when it's a high-level alarm, okay? So that's when we want it to start. And when do we want it to stop? Well, we want it to stop when the alarm is off. When the alarm is off, we want it to stop. And so what we do is we consider the reset and stop are both going to be falling, because we want this timer to stop and reset when our alarm condition clears. And our alarm condition clears when our tank drains to 50% capacity. And so that's the difference between this rising and falling and rising and falling. That's what that means. So you really have to think about it in terms of what it is that you're actually trying to accomplish. If I had something else for the input that wasn't an alarm, well, then all of these conditions would be totally different. So it really depends on what you're trying to do, and you have to think about it from a logical standpoint. So once we have that set up, now we've told the timer when we want it to do certain things, well, we also have to think about something else. We want to make this into an alarm. When 20 minutes passes by, we want to make this an alarm. And so the best way to accomplish that is to have the timer count down. And I'll explain to you why in a couple slides. And so what we want to do is make sure this countdown box is checked. And for the sake of our example, I just made it 20 minutes. And so what this means is that when our timer starts counting, it's going to start at 20 minutes, and it's going to count down to 0. When it resets, or our alarm condition clears, that timer is going to reset to 20 minutes, and it's going to stay there until the timer starts again, at which point it counts down to 0. And again, if you guys have any questions or anything, feel free to ask her in the chat, because I have the chat box open right there. So with that said, now we want to take this and we want to turn this into an alarm. Okay, so we set up the timer and we told it how long, that we have the 20-minute countdown. We told the alarm how to behave. Well, now we want this to be able to trigger a totally different alarm. So what I do is I set up a new single source alarm, and I make my input that timer that we just created. That's the input to this alarm. Now, this gets a little bit tricky as well. Again, we have to think about this from a logical standpoint. We want this alarm to be true when our timer is off, okay? And our timer is off when it reaches 0 minutes, 0 seconds. We want this alarm to reset or go away when our alarm is on. When our timer is on. And our timer is on if it's either counting or showing a positive value, okay? And so that's why I had the countdown start at 20 minutes. Because even though it's not technically counting, because there is a value shown in the timer, we can consider that to be on. So just to recap, this alarm here is going to turn on when our timer is off. And our timer is going to turn off after 20 minutes. And then we want this alarm condition to clear when our timer turns back on. And our timer is technically on when our high tank level goes away, and then that resets our timer to 20 minutes. So hopefully that makes sense. I tried explaining it in the best way I could verbally. I do have, obviously, in much greater detail in the study guides, and I may have explained a little bit more clearly there. But that's basically how you can control based on an elapsed time or alarm. Now, we're talking about alarming here, but you can imagine if you wanted to, maybe you wanted to turn on a pump instead of an alarm after 20 minutes. Well, you could do that as well. So this is how you can alarm and control based on elapsed time. And I thought it was a pretty slick solution. Now, going into a more complicated situation, this is how we're going to configure a time to fill application. And so I wrote up a nice little problem here just so you just to set the scene, so to speak. So here's the problem. Your customer has a really large tank, and it takes hours to fill it. And because it takes hours, the operator doesn't want to just stand around watching this tank being filled for a couple hours. He's got a lot more important things to do. So they want to be able to walk away from the tank, go do something else, and then when there's about 15 minutes left until the tank is full or so, they want to be able to go back and make sure that the tank's not going to overfill for the last 15 minutes. So how do we do that? Well, with a consolidator, we do some clever math. We use our rate of change channel, and we are able to display how long it's going to take until the tank is at full capacity. And that's going to be dependent on the tank fill rate and the amount of volume, amount of material we have in the tank. So those two conditions are changing over time, yet the Consolidator Plus can still provide you with an accurate readout of how long it's going to take. So check it out. So the first thing we want to do is we want to create a constant channel. And the reason why we want to do that is because we want to know how large the tank is. Okay, so we need to know, first of all, how many gallons is in this tank. I need to know the max capacity. And so what we want to do is create a math channel with the function constant. And you can see it's right there. You choose the function for a channel. You go to the math category, and it's right there on the top, constant. So once we pick that, then we have to choose a few other things. We have to select our units. So in this case, we're going to do our units in gallons. And then we choose our constant. What is our value going to be? So since this is a 1,000-gallon tank, I made my constant 1,000 because that makes sense, right? And that's basically it. So that's our first step right there, is create a constant channel, and that's our maximum tank volume. Now the next thing we want to do is we also want to set up another math channel, except this math channel is actually going to be doing the difference. We're actually going to be subtracting. And so what are we going to be subtracting? Well, we are going to be subtracting whatever our current tank reading is, so that's whatever is in the tank. We're going to subtract that value from our tank constant. And that makes sense, right? We always wanted to know how much further we have to go until we're full. And so the answer, the difference in this channel, that's going to give us how much volume we have left until we're full. Okay, so hopefully that makes sense. So the first thing we do is set up a constant. We set up a math channel where we're going to take our current tank reading away from our constant. And then we create another channel. And this channel is going to be a rate of change channel. And this is something I introduced to you a few times. A few people have actually commented on it, thinking it's a really cool feature. And so this is where it gets really, really, really cool. So we want to go ahead and create a rate of change channel, and this is for our tank 1 reading. And so basically what we're doing is we're trying to capture what the rate of change is in this tank. Or think of it this way. Instead of measuring the difference, instead of measuring the rate of change within the tank with a level sensor, just imagine for a second that this is a flow meter feeding the tank. Now that should make sense, right? So that's what we're trying to simulate here basically, is we want to know how quickly the rate of change is or how much volume is being pumped into the tank. So we make tank 1 the input to this rate of change channel. And our units, and this is going to be very important, our units need to be in gallons per minute, okay? So it needs to be in gallons because that's what everything else is scaled in. So all of our units need to agree. And we want to do it per minute simply because that's a normal flow rate and the numbers look much nicer like that. If you use seconds or hours or days, the numbers that display are they're not really usable. I mean, the real numbers, they're just not. I mean, is it going to really make a difference if I tell you it takes 2,000 seconds to fill the tank, or would a couple minutes look a little better? That's what I mean by that. So our unit's going to be in gallons per minute. Now, the next thing we want to do is we want to create another math channel, except we're going to divide. Okay, so here's what we do. We want to take the difference between the tank reading and our constant channel divided by our rate of change. So here's how I thought. I explained this in the study guide, how I thought this through, and I was thinking about a GPS. And I thought about, well, what does the GPS know about? When it tells you your ETA, and it's usually pretty damn accurate, well, how does it know? Well, it knows three things about you. It knows where your destination is. It knows how far away you are from that destination at all times. And it knows your rate of change or your acceleration. It knows how fast you're going. And so if you think about it that way, you go, oh, well, wait a minute. All I have to do is know how much space I have left until I'm at the end and divide that by my speed, and I should get how long it's going to take me to get there. And that's exactly what I'm doing here. It's exactly what I'm doing here. I'm taking the difference between our level reading, how much is in the tank, subtracted from our constant channel, and then we're dividing that by our rate of change. And the answer we get is actually minutes, okay? Because basically what we're doing is we're taking gallons, we're dividing it by gallons per minute. Gallons cancel each other out because they're the same unit of measure, and we're left with an answer that's in minutes. And it's really, really cool. And so let me just go ahead and set something real quick. Okay, so with that, the next step is to basically just go ahead and create an alarm or something that would enunciate when there's 15 minutes left until the tank is full. That way you can get the operator's attention back to the tank. So hopefully that all made sense. I know it was a little tricky. I explained it much clearer in the study guide, and I know with all the different math functions it may have gotten a little confusing there. But basically all we're doing is thinking about it in terms of how much volume we have in our tank, how much room there is left until it's 100% full, and how quickly we're changing over time. With those three pieces of information, that's how we do this. And so, since we have a few more minutes, I'm going to take 1 second here and find my camera application so that I can actually show you this very application working. That's not what I want. Alrighty, so let's just hope this works. Let's see. All right. All right, I'm just going to share my desktop. All right, so you should be able to see my ConsoliDator Plus demo on your screen. And if you don't, then I apologize. If you don't, I will send you a personal video of this happening. So what we have on the screen here is we have a 1,000-gallon tank. So this tank is supposed to have 1,000 gallons in it. And what I'm also showing you is our current reading, so how many gallons are in the tank currently. We have our tank fill rate, and we have our time until full. And so basically, I set up this simulation just to show you that it actually does make sense. If I have a 1,000-gallon tank and my tank fill rate is 100 gallons per minute, it should take me 10 minutes to fill that tank, right? That makes sense. But go ahead and check this out. I'm going to take that off of the simulate function, and now I'm basing this off just my raw 4 to 20 signal. And as the level increases, you'll notice that as my fill rate varies, which could happen, and as the amount of volume in the tank varies, my time until full updates, and it updates accordingly. So even if I go ahead and shoot this all the way up here, our time adjusts. You see that? Until we get all the way to the top there, and now it's close to 0 minutes because we're already at the top. So I thought that was a pretty cool application. This is something that came up. A customer had this request. We weren't able to do this a couple of years ago without the consolidator, but now we can. And this is exactly how it's done. Let's see. Alrighty. So with that, that's all I have for you as far as the class materials go. So we have a couple questions that came in, and I'm going to go ahead and take a look. So somebody asked, when setting the schedule, I didn't see an AM/PM choice. Aha! Great observation, and that's something I do mention in the study guide that I forgot to mention in the slide deck. So it's a 24-hour clock. It's always going to be a 24-hour clock, so there is no AM or PM, and that's actually precisely why I chose noon and noon 30, because otherwise I would have said 1300 for the time. For those who aren't familiar with 24-hour time, I didn't want to confuse anyone, but yes, it's our clock's a 24-hour clock, which just for kicks, I actually use 24-hour time on my cell phone. Like right now it's on the East Coast, it's 16:26. Anyone else have any questions or anything? Was anyone confused by anything I went over today? Was this something that was maybe too much? Did I go too quickly or anything? If you have any feedback like that, please do let me know. So somebody asked, can I set an alarm value so you know when it reaches full? So yes, we can. So we can set an alarm value so that we know when it's totally full. Absolutely can do that. The point of this exercise was so that we can actually set an alarm for before it's totally full. That way an operator can go back and make sure for the last 10 or 15 minutes or so that nothing's going to go wrong. So, but yes, we could do that. Someone else asked if I sent out the study guide for week 9. So I think I did, but the fact that you're asking probably means I didn't. So I'll go back and check, and I'll send them all out if I didn't. So if you don't have it, it's most likely because I forgot to send it out. That's my bad. Someone else said it was well presented. I appreciate that. It is a little tricky to try to present this type of information on a slide deck. And while we're all here, like I mentioned at the very beginning, this is week 10. This is only a 12-week course, so we're at the end, okay? So next week, we're going to go over math functions. It's actually going to be a pretty quick class because obviously it's not a math class. I'm not going to teach you how to do math. We're just going to go over the different math functions the ConsoliDator Plus has, how it can be used to your advantage, and then that'll be it. And then we have week 12, so that's going to be, it's a surprise. It's going to be a surprise what the last week is going to be. I'm going to try to make it fun. So, yeah. Oh, and as a reminder, folks, that competition is still ongoing. We did get our first winner. So just to remind everyone, it's the Stump the Consolidator Plus competition. If you can send me a quote-unquote reasonable application, and I cannot program the Consolidator Plus to do it, then I will send you a free PD9502, which is a 4 to 20 milliamp signal generator. Like I said, we've already gotten one. We've had 5 submissions and 1 winner. So that's pretty good. Pretty good. Alrighty. Well, with that, I'm going to go ahead and let you folks go, and we will see you on Monday afternoon. And I hope you guys have a really great week. Thanks for joining me.